Hi guys, hope all of us are doing great. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. In my channel, I deal with different subjects ranging from mathematics, physics, chemistry, and biology. And today we're going to look at the concept of a quadratic formula. And this, of course, is one of the strategies that we're going to use in trying to solve what we refer to as quadratic equations. And of course, I've given from our first video, I'm going to put a link in the description box on the various types of equations. We had said that we can be able to have a general representation for quadratic equations in a form of ax squared plus bx plus c given as start, and that's going to give us the product of 0. So in this particular case, we said that we are going to have the variables a, b, or the coefficients of a, b, and c being given as real numbers, whereby a is not going to be equivalent to 0 given as such. So if you try to look at this specific equation, we can be able to give it in terms of x, whereby we are going to have it represented as ax squared plus bx plus c is equivalent to 0. So we can have a variation of that formula whereby we're going to have a bx over a is equivalent to negative c over a given as such. So I've divided both sides by a to give that variant form of that specific equation. So in this case, we had said that one of the ways in which we can be able to find roots of quadratic equations of values is through factorization method, completing the square, or using this specific concept of a quadratic formula. So in this case, if I try to look at the left-hand side, I can introduce a factor there which is going to assist me, of course, give it as a square of a particular number. So therefore, I'm going to use the concept of b over 2a, which are factors of this specific equation. So I'm going to have the square of b plus bx over a plus b over 2a given as such, and I'm going to square this so that it is easier for me to try and factor out those specific part of the equation. So I've introduced the b over 2a on both sides, which is a square, and so therefore from this one I can be able to factor out and find the root of that one to be x plus b over 2a, and this is going to be the square, which is going to give me a product of this particular part on the left part of the equation, and the other side is going, of course, to give me minus c over a plus the square of b over 4a squared. So if I look for the common factor on this negative on this right part of the equation, I'm going to have it given as b over 2a, the square of that, and this is going to be over the common factor for a squared, and then we're going to have negative 4ac plus b squared given as such. So therefore I'm going to make this open this specific square sign. So I'm going to have this one given as b over 2a. So I'm going to square to find a root for both sides, whereby I'm going to have this one given as the root. So for this particular case, for the numerator of this second or the right part of the equation, this is going to give me a positive or negative value over this particular factor for b squared minus 4ac. So I've rearranged this one for a positive value to come first. So, and then this is going to be the root over the denominator is going to be 2a given as such, and then therefore I'm going to have this one given as the value of x is equivalent to negative b over 2a, and then plus or minus the root of b squared minus 4ac, and this, all of this is going to be on 2a. So if you try to look at this, it's going to have a common a denominator. So I can be able to represent the value of x using negative b plus or minus at the root of b squared minus 4ac, and all of these are going to be under the common denominator of 2a given as such. So this one is going to give us a general representation for the quadratic formula, and of course we're going to use this one in trying to represent various forms of these specific solutions for quadratic equations. So the expression in this particular formula, which is given as the square of b 4ac, is going to represent what we refer to as the discriminant, and the discriminant of course is going to dictate on what particular roots we're going to obtain from this. And in this case, if for the function of fx is equivalent to 0, as we had said from this specific equation, we're going to see that we're going to have two distinct roots, and of course, so in this case I can be able to give it in terms of this particular value for the discriminant, whereby we're going to have, if the value of the square of b from this one is going to be greater than 4ac, which is the second part of this particular part of the equation, then we're going to have two real roots, or two distinct roots from this particular case. And if the value for b, the square of b, is going to be equivalent to 4ac, then we're going to have what we call two similar roots, similar or equal roots in that specific case. And if the value of the square of b is greater than 4ac, then we're going to have what we refer to as imaginary or non-real roots in that specific case. So as we had mentioned earlier, of course, we're going to have this particular value for the function if x of x equivalent to 0 given as c. So that is just a direct substitution of this specific value. But if we are going to have the value of x varying in a sense that if x is tending to positive or negative infinity, then we're going to have the value of a greater than 0, whereby the function fx is going to be tending towards positive infinity given as such. And then if we have the value of in this specific case, if we have the value of a smaller than 0, we're going to have the function fx tending to negative infinity, and those are the two specific conditions for that. So in this case, if the value of the function of fx is equal or greater than 0, we're going to refer to this specific of course value for the function of fx as the minimum value. And this is the case whereby x is going to be equivalent to negative b over 2a given as such. So if the value of the function fx is going to be, of course, smaller than or equivalent to this specific part of the equation, then we're going to have the value for a smaller than 0, and we're going to refer to that value as the minimum value when, of course, the value of x is going to be equivalent to negative b over 2a. And of course, therefore, this is going to give an implication of what we have already mentioned in this particular case. Now, the application of this quadratic formula is going to be widely, of course, expressed, especially in our concept of what we refer to as complex numbers, as we're going to discuss about various roots of numbers. And this is going to be the case, of course, especially when we're going to see that this is going to be a negative value, as we have mentioned, whereby we are going to see the concept of imaginary numbers, or what we refer to as non-real roots, and that's going to form a basis for us in describing various aspects of complex numbers. So that is it for now, guys. Okay, bye. God bless you. Catch us in our next video.